Now, if we have a function f with domain x and codomain y, so we're sending elements of x into y, or in other words, assigning the elements of x function values, then we can talk about the images of sets and inverse images of sets. So in particular, if we look at some of the elements of the domain, let's call that A, then we can find the image of A to be all the function values that we get if we apply the function to the elements of A. The inverse image of B is all the x values, all the domain values, in other words, that have function value within B. So you can look at the two images, the image there and the inverse image in this sort of way. You have x and y here. You've got the function f taking the x values over and assigning y values to them, or function values to them. And if we have subset A here, then the function values that we get by applying the function to it here will give us the image of A. So this is f of A. And if you can't read that, I'll write it again a little bit bigger, f of A. And for the inverse image, we have this situation here, where we look at a subset of the codomain. So let's call that B. And we're asking, and here is f again, we're asking which elements hit this, which elements over here, which little x's hit the function values in here. And we look at all of the x value, the values here in x that do that, and that gives us a set, namely the inverse image of B. So in the example that I had with x being equal to the students, U students who are taking the course here, and the y set to be equal to the marks from 0 to 100, well, hopefully the image of any set of U students will be just the 1 mark 100. Yay! Okay, maybe that's a tiny bit optimistic, but hopefully that would be nice. Now, the inverse image, of, if we're talking about that mark-giving function, for instance, the set of marks 0 up to 84. Let's hope that is empty. Let's say that there are no function values that actually get sent to there, and we could also have a final example here, that the inverse image of, let's say, 100, the little set containing the mark 100, so that's a very small example of B there, that's all of you students x. So this is the way that we're thinking about it. So in particular, if you're looking at the empty set, the image of an empty set, well, that's empty. If you're looking at the whole set x, well, that's exactly the range of the function itself. So the image and the inverse image are important and useful notions that we now have. Now let's look at an example. So here we have an example of the image and inverse image of a particular function. Here we've got a function going from x to y. So x is here the elements a, b, c, d, e, and the function values are, or rather the domain values are 1, 2, 3, 4. So they are the possible function values that we might have. You do note that 1, for instance, is not a function value. That arrow there, that signifies the function here. It's not going from a to 1. A goes to 3 over there. And we should just basically, check very quickly that this actually is a function. And we see a, b, c, d, e, each of them have exactly one function value and no more than one. So yes, this is a function. So we've been given two sets here, A and B, And A is a subset of the domain, B is a subset of the codomain, just like over there. And we have to find then the image of A, and that's the image of, well, what are the elements of A? They are A, B, and E. So we have to find the function values of those three elements. A goes to 3, so we have a 3 there, and B goes to 2, and E goes to 3 as well, and we're talking about a set here, so we have to get rid of multiples, and we're just left with the set containing, if we write it up nicely, 2 and 3. So that's the image of that particular set A. The inverse image of the set B here, that's what we get if we look at, well, we have the inverse image of the set of numbers 1, 2, and 4, the potential function values, and we're asking which of the elements over here in the domain actually have those, one of these function values as its function value. So 1, how many elements over there have function value 1? None of them do, so we don't have to worry about 1. We're allowed to look at the inverse image still, included there, but we're not going to get any resulting domain elements in our set here. What about 2? Well, we have that B and D, they have function values equal to 2, or their function value is equal to 2 in the singular. What about 4? That's the third value we're looking at, and we're asking which elements have 4 as their function value, and that's just the element C. So here we have our inverse image of B. It's the elements B, D, and C. So this is images and inverse images. So here's an exercise. So you might want to pause the video and try to solve these 3 questions yourself, and I'll give you time to do that now. Okay, so we have to find the image of a set and then 2 inverse images of 2 different sets here. So we're talking about the real function defined on the reals by x squared. So just the normal simple function x squared. And if we look at the first set here, we've got 2, minus 2, pi, and 2, root 2, that we have to put into the function and get whatever we get. That'll be the image of that set. So if we look, we have 2 squared, that's 4. We have minus 2 squared, that's also 4, so we don't need to write it up again. We have pi squared, and we have the root 2 squared, which is just 2. So this is the image of that set there. Now the inverse image there, we have to look at each of these elements in turn, 9, minus 1, and pi, and ask what numbers in the domain, what real numbers there, give any of those numbers if we plug them into the function. So, well, for 9 we could have 3, so f of 3 is equal to 9, but so is minus 3, so plus or minus 3 will give us 9. So we certainly have in our inverse image here minus 3 and plus 3. What else do we have? Well, minus 9, we never get that as the square of a number, so we don't have to worry about that. Pi, what do we have there? Well, we have plus and minus root pi, so plus and minus root pi will give us, if we plug each of these into the function, just pi, so we have minus root pi and root pi, and that's a little messily written. That's our inverse image. Now for the final one, we have the 2 numbers here, minus 2 and minus 9, and we're asking which real numbers, when you square them, when you put them into this function, give us one of these numbers, and the answer is none, because we can't get negative numbers from this function. So this set is empty. That is exactly how many, there are no elements from the domain which give us these function values when we insert them into the function.